On the calculator, let's compare the graphs of y equals x squared plus 5. So the plus 5 is outside the squaring function, notice. So here, plus 5 is you're adding 5 to the squaring function, adding 5 to the squaring function. If you think of y equals x squared as the squaring function, right? Whereas with y equals quantity x minus 5 squared, that's a little different, right? So you're really sticking the minus 5 inside the squaring function, attaching it to the input, right? So what that really means is for every input x, you're subtracting 5 from it, and then you're squaring, right, to get the output. The other way around, you're squaring, whatever your input is, you're squaring it first, and then you're adding 5. So that's going to affect the position of the graph. The shape, you'll notice, is going to be the same. Y equals x squared, the shape of y equals x squared plus 5, y equals x minus 5 quantity squared. They're all going to be the same. They're just going to be in different positions on the xy plane. So let's do this on the calculator to save some time. Go to y equals, we'll plot x squared. And let's do it all on the same graph so we can compare. Y equals x squared minus 5. So the second graph that gets plotted will be x squared minus 5. Y equals x squared minus 5. The first graph that gets plotted will be y equals x squared. And the last graph will be, okay, x minus 5 in parentheses, that whole quantity squared. Okay, now I'm going to turn off the graph to the third one. And I'm going to make you guys guess at where it's going to be. So they're all going to be the same shape, that happy little parabola that opens up, same width as y equals x squared. But they'll be in different positions. So I'm going to make you guess based on y equals x squared minus 5. And using your intuition, I'm going to make you guess on where y equals x minus 5 quantity squared will be. So if we do that, whoops, okay, close your eyes. That's not what I wanted. Let me go to, I wanted to graph it on a standard screen. Come on. There we go. Okay, now it's going to go on a standard screen, negative 10 to 10 on both axes. Here we go. So here is y equals x squared. And then next up, y equals x squared minus 5. Now, the graph in red kind of looks like it's wider, right? It's not. It's just because it's pulled down further. In fact, what is the observation then? So the graph in red is y equals x squared minus 5. All we did to go from the graph in blue to the graph in red was move the graph in blue down 5 spots. Would you agree with that? Now that should make total sense to you. Because look, essentially what we're doing, oh, I used minus there, didn't I? And I said use plus. All right, take 2. Yeah. Well, it's going to be, what's your prediction? This is a good opportunity to predict. What's x squared plus 5 going to look like then? In comparison with y equals x squared, it's going to be y equals x squared, the same picture except it'll be moved up 5. Okay, so that's our prediction. So the graph in blue, y equals x squared. The graph in red, y equals x squared plus 5. So to go from the graph in blue to the graph in red, you just move the graph in blue up 5 spots. And that should make total sense to you. Why? Because we're adding 5 to the original squaring function in this, to graph this guy, we're adding 5 to the original squaring function. Well, the output is x squared, right? Y is x squared. So we're essentially adding 5 to all the y values. When you see this equation, x squared plus 5, we're adding 5 to all the y values that comprise the graph of y equals x squared. So that should make total sense to you. You add 5 to all the y values, that's going to shift the graph up 5 spots, right? You subtract 5, it's going to shift it down 5 spots. Okay, but what's your prediction for this one? When you're subtracting 5 from the input value of x in comparison with the original squaring function, what do you think that'll do to the graph of the original squaring function? How will it move? Probably horizontally, right? Left or right? Which do you think it'll be, left 5 or right 5? Ooh. If you had never seen it before, what do you think it would be? You would think left 5, right? But you guys were right the first time. It is right 5. So let me show you, and then we'll talk about why. So if we go ahead and turn the third graph on, the third graph will be a shift of the graph in blue to the right 5 units. You can count 1, 2, 3, 4, 5. So why would that be? We subtracted, and we ended up moving to the right 5 units in comparison with, of course, the original guy. Well, that's because you'd have to plug, in order to get to a height of 0 on this graph, you plug in 0, right? The input is 0. To get to a height of 0, to get to an output of 0, you make the input 0, right? To get to an output of 0 on this graph, you would have to input 5, right? Because 5 minus 5 is 0, squared is 0. So it has the effect of moving not just that point at 0, 0 to the right 5, but the whole graph. It does that for every point on the graph and moves the entire graph to the right 5 units.